database. What are they? All these things are things we're going to be looking at. They are pure, like they are simply just pure theoretical things that we have to like familiarize ourselves with. Next slide. This is I've been calling SQL, SQL, SQL. What is SQL? SQL is an acronym that stands for Structured Query Language. That is why I said we will not be doing data visualization, but we'll be using queries to answer business questions. I don't know if you get if you are following at all. So now SQL, note it today. It is not structure any other thing. It is structured query language, because sometimes in an interview they could just ask you what is SQL. All right, what's the full definition of SQL? And you can just answer network. Yes, can you hear me now? Sorry, I was able to catch that because I could hear myself on the other device. So let me just reshare. So I was saying that in an interview, you might be asked what is the full acronym of SQL, or the full meaning of the acronym SQL. It simply stands for Structured Query Language. That is the first lesson I want you to learn today. Now, the next thing is that its definition. It is a programming language used to interact with the database. So, in a nutshell, SQL is a programming language, all right, but it is used to communicate with the database. I don't know if somebody is getting the explanation.
Yes, please.
Okay. Now, the next thing I want to mention is SQL applications. When I mean applications, what is SQL used for? Number one, you can see on this my screen, I have a beautiful uh, abbreviation called CRUD. CRUD. That's C stands for create, R stands for read, U stands for update, D stands for delete. So it's simply an acronym, but with this acronym, you can know what are the applications of SQL. Letter C now, let's talk about letter C. The create. Any day, anytime you are asked to create either a database or a table, you use the keyword create to create it, and to create either a database or to create a table. Why it is important is that it is the future, or it is the syntax that allows us create a database or create a table. So that is where it is applied in terms of either creating a database or creating a table. I don't know if you are following now. Now, letter R, which stands for read, it means any day, anytime you want to write into your database, that is, you want to like fill in records into your database, you use the read function. All right. Now, let's say a record is already existing in the database and you want to make modifications to it. You use the update keyword. All right. So you can see how they are being applied. And finally, the D. Any day you want to delete a record or delete a table or delete a database, as the case may involve, you use the delete keyword. So in a nutshell, I said here that read is the same thing as select. You'll be seeing select is one of the most used syntax in SQL. So you will not see me writing read. You might see me writing create. You might see me writing update. You might see me writing delete. But whenever I want to read, you will see me writing select. What it means is that I'm reading from the database. So anytime you see select, it means I am reading from the database. All right. Any question in this place before we proceed, please?
Yes, sir. I wanted to ask something.
Yes, go on.
Yeah. You mentioned databases and tables. So I wanted to know if they are interchangeable or they are the same.
Okay, no, they are not. We're still going to discuss that. I'll just summarize that. Let's put it like this: a database comprises of so many tables, but a table contains rows and column that stores a particular record. I'll give you this example. You can have one database that have student records. That means the first table will be called biodata. That means like the first name, last name, gender, age. Let's say that four columns now, they are stored in the biodata table. Still in that database, you can have, hello, stop sharing. Let me
Yeah, yeah,
confirm.
you're back on again. I can hear you now.
All right, okay. Let me try and share back my screen. So what I was trying to explain was that now you can now have the student record, like the biodata is information about the student, generally. Hello.
Yeah, you're on. We
We
can
can
hear
hear
you.
you.
Oh, this network is breaking. Let me. Trying to check my network. Hello, is it better now?
Yes, please. Okay.
Okay, so what I was trying to say that a database can have so many tables. I was trying to say that the database can have student biodata record. Still, that database have a another table called maybe registered course. That is, all students, only their ID, that is maybe their register number or their matric number, will be in the course and the list of the courses they registered. So in a nutshell, a table holds a unique record, but a database comprises of so many tables. I don't know if that's clear to you now.
Yes, that's clear. But the reason I asked is, what if a database just has one table? Does that make it
Yes.
like can you call it a database on or just table?
Okay. Yes. Provided you create, even if you create a database and there is no table inside, it's still a database. That doesn't change it. You get my point. But the amount of information in the database is what makes it relevant. Do you get it now?
Yes, please. Thank you
That
very
is
much,
the
sir.
amount of information. Somebody's database that doesn't have any information is not as relevant as somebody whose database is heavily loaded with tables and so many other factors that so many other informations compared to somebody that just created an empty database. All right. Okay. Um, is there any other question on the application before we move forward? All right. Now, we have two types of SQL. We have the SQL and we have the no SQL. What is the dissimilarities and what is the differences between them? The first similarity or the first differences between them, or rather, let me say it like this: SQL are relational databases. That is, they are relational database because they store record that contains similar information, just like Excel. You know, if you have a column that has dates, network. Let me take that again. Hello?
Yes, please. We can hear you.
Yeah, I said, let's say you have a table, an Excel rather, that has informations. You know, like like one of the column, let's say column A now, will have things like date of birth, and then everything there, it's all, all date to wherever. It's going to be date. That means in each row, they are related to each other database. Now, in the other hand, if the database is just storing not in a tabular format, it is called a non-relational database. I don't know, but let's just take that first. I'm going to ask if you have questions to clarify that. Now, we want to differentiate between what is a relational database and a non-relational database. The first thing I want you to note is that a relational database is an SQL database, and a non-relational database is a non-SQL database. Now, the second option here is the data in under relational database. The data stored is in a tabular format, while in a as a value pair, a document based, a graph based, or a column storage. So what that means is that I'll give you an example. I'm sure most of you have a Gmail or a Google Drive. And then your Google Drive contains all kinds of information, whether it is image, whether it is anything. It contains just any form of information. When you have something like that, that is simply a non-relational database. It doesn't follow any hierarchical order. It doesn't follow any systematic order. They are all just there. That means you can have images, you can have audios, files, folders. All of them are just located there, but they are not stored in a tabular format. But in a relational database, they must be. Let me pause and ask, do we have questions? Hello? Yeah, can anybody hear me? Yeah, I'm trying to. Uh, do we have any question, or can I proceed? Sorry, I can't see my screen. Message box. Do we have any message? All right. Judah, what you just need to do, just close it. You don't have to. You don't have to open it. We'll continue with that next class. Okay. Yes. All right. Now the next thing we have is that we said that a relational database have fixed or static or predefined schema. I will tell you, I'm sure most of you have done data modeling in Power BI. You notice that when you divide your table into fact and dimension table, there is a format that that the fact table will take, and there's a format that the dimension table will take. Because in the dimension table, you can have replica of all the information. But in the fact table, you want to keep it unique. If you understand what I'm saying, you will get it. So when we talk about relational database, it follows exactly the same principle. All right. So now in a relational database, there is a predefined schema or a static format. While in a non-relational database, there are dynamic. That is, it can be any format. All right. And I'm sure that is the fact and the dimension table. But when we have a non-relational database, it could be any format. All right. Now, a relational database has low performance when the data becomes very large. All right. While uh, yeah, sorry, Judah. Sorry, where did you hear me last too? I was still explaining the the database schema, where I said that for a relational database there is a predefined a non-relational database, it has a dynamic schema. That was what I was trying to explain before the network went out. Okay, so um hello, sorry, I muted myself. I just needed to do something. So now what I was let's go back to, I said that for a relational database, the performance is low. Why? Because it can handle large amount of data. But when it comes to non-relational database, they can handle very large amount of data in no time without problem. Most of these cases, just I'll give a good example. When you to look at Twitter, you know Twitter has a ton of users and everybody is tweeting and posting and resharing all the time. They could have a non-relational database like MongoDB, Cascadian, or hashtag, or sorry, or Hashbase, HBase rather, that handles all those tasks for you. But for the core fundamentals, they use relational database like information, like you're logging in. But when it comes to the post itself, they use a non-relational database. All right. Now, example of a a relational database and non-relational database. Example of relational database first include Postgres SQL, MySQL, Microsoft SQL Server. And it's the Microsoft SQL Server we'll be using for this class. Then an example of non-relational database, we have MongoDB, we have Cascadian, and then HBase. Yeah, I would want to pause here and take your questions before we proceed. Yes, any question so far? You don't understand any of the concept I mentioned, you could just point it out. Then I try to re-explain before we proceed. Okay, Jerry has dropped the attendance, so please try and put your attendance. No. Okay, sorry. Yeah, I was saying, please take your attendance. And secondly, do we have questions in the house, or it is well understood if I can continue with my explanation? Just want to confirm that before I proceed. Because at the end of the day, you should be able to differentiate between what is a relational database and non-relational database, what is SQL. We have mentioned this evening. All right. The next slide I have here is the SQL command. We have four of it that we'll be talking about. We have the DDL, which stands
Sorry,
for.
sir, your screen is not showing. You're not sharing your
Okay,
screen.
okay. Let me confirm that. Okay, I'm not sharing yet. All right. Can you see it now?
Yes, please.
All right. The first one we have is the SQL commands, and then we said we'll be discussing four of it. One is DDL, which stands for Data Definition Language. Um, okay, can you hear me? I said the first one is DDL, which stands for Data Definition Language. In this case here, we use them to define SQL commands that could either define to create, to alter, or to delete a database because they are used in a definite way. And I said it simply deals with describing the database schema, and it uses it to create and modify the structure of the object in the database. An example of DDL commands are one, create, alter, then truncate and drop. These are examples of DDL command. If you use create, it's going to create and modify the structure of the database. If you use alter, that means you are modifying the structure of the database. You can alter to add a new column, or you can alter to add a new row. Then truncate, you can truncate the entire, that means deleting the entire information in the table, but not the table itself. Drop, it means you are deleting the table itself. All these are strong keywords that we use to define how our database works. All right. Then We have just right under it, we have the DML. It stands for data manipulation languages. Now, these are used to manipulate data stored in a database or a table. All right. They are used to modify the structure or update the structure of the table. Example is the insert, update, and delete. This allows you to modify or manipulate the structure of your database. If you use insert, let's say you have a database and you have some table inside and you want to insert into your table, you use the keyword insert. If you want to update the record inside the table, you use keywords like update. Now, delete allows you delete a single column. Now, I would later differentiate in the course of this class what is the difference between drop and delete. Drop and delete are totally different, but they are similar. Drop, we drop the table, that means delete the table completely. But delete can delete a single column within a table and not the entire table. But once you say drop, it's going to delete the entire table. They are similar, but they are different. Now, at the top right, we have DCL, which stands for Data Control Language. It includes commands such as grant and revoke. They are used to set rights and permissions to users. Right now, the other day we used system authentication. So you have the right to revoke access depending on who you want to access your database. So in cases like that, you use DLC languages, all right, which is for the control language. Now, finally, we have DLQ. Now, the DLQ is simply data query language. This is the most used and most ones we use to answer questions. Now, they help us to fetch record from the database, but don't forget we have to add keywords like select to help us retrieve it. Let's say I said I want to see everybody in the Department of Finance. I will have to say select maybe finance table where, or sorry, select select employees table where department is equal to finance. You get my point? So that would allow me fetch everybody in the finance department. So data query language are used specifically for fetching data from the database. You are not using it to impute, you are using it to query the database and get out information from the database. And it is one of the most powerful and useful of all of them. All of them is important, but it is the one you use as business analyst to answer those questions you want to answer. All right? Questions about this, please. Any question? It's like we are all getting it. Okay. Next slide. I defined what is data and what is database. I've been calling database, database, database. What is actually database? But I felt like before I mention what is database, I'm sure you already know it, but I just want to re-emphasize it that data is simply a piece of information. This could be numbers, whole numbers, words, image, anything. That's just data. Okay. Now, data can be processed or raw. That's just an explanation for that. Now, what is database? A database is a collection of data that are organized in a way to facilitate efficient and reliable way of manipulating those information. That is, a database they are organized. That's the first thing. They are organized in an effective way. That is, that helps you to quickly retrieve informations that are important, manipulate informations within the database. All right. Now, um, it acts like a central and organized repository where data are stored, managed, and accessed by various applications or users. I'll give you a real world example. I'm sure most of us have either Facebook, Instagram, TikTok, any social media platform. And then you see, especially the social media platforms that has to do with with video, like TikTok specifically or YouTube Short. You notice that whenever you go to the site, you just open it and then you are welcomed with a video that is already playing. I think this network. Hello, can you hear me?
Yes, please. We can hear you.
All right. So let me go back then. So I was like, let's say those social media platforms now, anytime you want to use them, they access their information from a database. So now those right.
Yeah, sorry, my laptop is reconnecting. I'll be with you in a minute, please.
Hello. Yeah, sorry. I think let me share my screen. Okay, so I was explaining that the database helps companies like YouTube, TikTok to store their data and manage the informations that people upload and have within those databases. All right. So now the process. So, sorry, let me present. Okay. So now the process of all that happens is called database management system. That's a database management system. Now, I said it is a software that that enables users to define, create, maintain, and manipulate databases. It provides an interface between the database and the users. So now, DBMLs, which is the database management system, is what most of this organization uses. Now, you might say, how is it important to us? You are an analyst, and then you need to analyze information about users. You have to be able to manipulate the data found in the database systems to understand clearly what is the customers or the users need, what is their preference. So in a nutshell, it's also important that database management system, it's a course on its own, but the core idea there is that they help to manipulate data, create data, and then the way it exists. All right. So let's next slide. Okay. My next slide here is talking about what are the different SQL database. I've told you what a database. We have two of it, the relational database and the non-relational database. Examples of the relational database includes like the first one here, MySQL, Postgres, Oracle DB, uh, this is MySQL, Microsoft SQL, Amazon RDB. All these are relational database. Then at the other side of it, we have MongoDB, we have Firestone, we have colons, we have JSONs, we have Redis. These are non-relational database. Now, all these are this other side where we have Teradata, Amazon RDS, IBM DB2, Oracle database, SQL, Snowflakes, SPR, then SH4 HANA, Postgres, MySQL, and Microsoft SQL Server. All these are still databases. Now, I'm sure you are aware as a data analyst that it's not only Power BI you can use for data visualization. You can use Google Studio, you can use Tableau, you can use Power BI, but you know that all of them are for data visualization, but they are from different companies, different purposes, different reasons, but all of them still does visualization. That same idea is what is happening here. All these are databases, but they are from different parent company, and then each parent company have their own database. But one thing is common, all of them uses a language called SQL, which is structured query language. That is why it is important in this class that we learn it. Why? I know that by God's grace, tomorrow now, in latest, soonest, you will get an offer from a company. If the company uses any of this database, the idea you have learning SQL is what will help you thrive in that organization. I don't know if somebody is getting my point. I know this evening is plenty talk. Don't worry, when we start writing it, we'll be writing plenty things, but uh this is just like the boring part of it. So I just want to get it over with once and for all. So I said in a quick note down there, I said SQL database, databases. Now we have different types of database from classical SQL are all trending, which could be no SQL, even cloud-based databases. But most of them can be used across platforms like web development, mobile development, DevOps, data engineering, data science, artificial intelligence, and cloud computing, even in blockchain and Web3. All these databases are still what people use. You get my point. So the idea is that we want to learn the language to communicate with all these databases. So that's what we'll be focused on in this class. Okay. So now I would pause here and I'll take one or two questions before we proceed, please. Yeah, questions, please. Yes, any question from the house?
Good evening. I don't know if you can hear me. Sorry, I'm disconnected.
Yes, I'm
Good evening.
Judah. I can hear you.
Yes.
Yeah, good
Okay.
evening.
So I just wanted to ask because I know someone that is a database administrator. I was wanting to know if basically all they use is just SQL and just few. Can a data analyst work as a database administrator? Basically, that's what I'm asking.
You need a good knowledge of SQL
Yeah.
and other things to work in SQL things. You need to know things like how to normalize database. I'm sure some of you ran away from uh, data modeling, localization, and so many things that will help you work effectively as a database management officer or management person. All right.
Okay. Yeah. All right. Thank you.
Yeah.
And also, sir, I don't know if we
Okay.
can get the material too
Yes.
in
Any
the
other
group.
question? Yes, I currently I can send this to you, but I wanted to complete it and send to you. I'm already
Yeah. No. No. I know. By the end of the class is
almost
what I mean.
done.
By
Unless you
the end of
just
the
want to
class.
send you at the end of this class, I will send you what I have completed for the class so that next class.
All right. All right. Thank you.
Yeah, my mobile is connected, but my PC is again, please.
All right. I would just proceed in absence of no other question. But let me just check the chat and be sure that we are all in the same paragraph and line. First, shit. Okay. I think there is some issue about the attendance. I don't know. Just make sure you fill the attendance. Okay, let me share my screen. Now we'll be moving into the next module. We have looked at key introduction in this first module where we talked about SQL, no SQL, database, and the likes. The next thing we'll be looking at is creating a table, creating a database, what are foreign keys, what are primary keys, and the likes. But there are some key terminologies I would want us to explain. We are going to this particular session has some practical aspects and some theoretical part. So we are going to be looking at the theoretical part, and then in our next class officially we'll be starting our practicals. So data types. Can anybody? I want to throw it to the house. Can anybody tell me based on what you have done in Excel and Power BI? Because I know a beautiful job was done there. Can anybody tell me two examples of data type found in Excel, another two in Power BI, anything like that? Or what do you even understand as data type? I'm sure this is not the first time you are hearing it. I need somebody to talk before I proceed. I want to engage us. This I've been the only one talking since, so yeah, let's talk. Anybody? I have sweet for the person. Just tom.
Hello, sir. I would say a data type for Excel, I think text, dates, or numbers.
Okay. Yes. All right. Text and numbers. What of Power BI? Do you know any specific one for Power BI? Mm, DAX is not a data type. Please don't mix it. DAX is a language used to write measure. It's not, we have text, we have blob, yes. We have
Whole number.
decimal. That's good. That's good. Yeah, whole number exactly. All these are data. Thing is applicable in SQL. So we have hello.
Yes, please.
Yeah, so I said we'll be looking at the core types of data type we have in SQL as well. So I said data type, what to SQL, we often use the data type and they are always defined before the data is put into it. Unlike unlike when we have other types of like Excel, you can just have a general data type and later you you now select different types of data. You now go column wise and choose the data type for each of them. But when it comes to SQL, you have to define it first. So when you define it, it depends on what you define that it's float. Or sorry, let's say if you define integer, it is only going to store the integer data type. That means numbers, whole numbers like one, two, three. That is only what is going to store. All right. Now, if you define a data type of float, that is when it can store data types like 1.1, 1.2, 1.3, and the likes like that. I don't know if somebody is getting the point. So basically, the column, a column, is what defines the type of data that is stored on that row. think that or sorry, I needed to just off the Wi-Fi and try to connect back because it was seriously breaking, and I don't want a case that is that bad in interrupting you. I think it should be better now. So I would also try and still watch from my own device here. I think it's better now, please. Sorry for that. I intentionally stopped it because it was cracking in my own ears, and I was thinking that's so bad. I needed to just fix that immediately. All right. Pardon me for that. Okay, so now what I was trying to say or about data type is that in SQL is the data type that you define that defines that if you define integer, it is only going to store integer. Unlike Excel or Power BI that you could fix it later. So in this case, it is only going to store the data that is specifically specified for it. All right. So that's the first thing. Then the other thing there is that it is defined unlike other ones, it is defined when creating the table. That is, when you are creating the table, you have to define the type of data type that column is going to store. All right. Then the third option, it says that data type are mainly classified in three categories. There are more, but in most cases, because you will be working across different databases, but in most cases, you have three categories. You have the string, and the string data type could be either varchar or character. Anytime you see CHAR, that is character. Anytime you see VARCHAR, that is varchar. So that's any of these two is a string data type. Then we have the numeric. Now, numeric could be integer, float. In some cases, you have decimal. You have boolean. All right. Boolean is simply true or false. Now, finally, you have the date type. The date type could either be a or the date time. It could be a date or the date time. So these are the three data type we have in SQL. All right. Um, questions or let me just finish this then ask the question. I now said the next slide here. They include one integer, which which is used for integer values. All right, int is used for integer values. Then we have float. They are used to specify decimal points. Then we have booleans. They are used to specify a true or false case. Then we also have character. This is a fixed length string that contains numbers, letter, or special characters. Then we have varchar. This is a variable length string that contains numbers, letter, or special characters as well. Then we have the date. Date is it stores the date format YYMMDD, which is definitely your year, your month, and the day. Then we have the date time, which is a combination of both the day and the time. And usually it's YYDDMM, then hours, minutes, and seconds. HH is simply the hours, MM is the minutes, SS is the seconds. So anytime you have, and that is what we usually call timestamp. I don't know. I think that is that. Questions, please, on data type. Um, any of these ones that you did not get, I could re-explain, and where it is used, I could explain that briefly. Yeah, can you hear me?
Yes, please. We can hear you.
All right. So you got all the data types we have, right? So if they tell you to mention three main categories of data type, and you are also asked to mention what are the common data types in these categories, you should be able to mention some of them. So slide 13 here, we have the primary key and the foreign key. So basically, these two entities, we are going to use them practically, but I just need you to understand what they are used for and how what it is by definition. A primary key is a unique column we set in our table to easily identify and locate data in our query. I'll give you an example. In a school settings, there's always called either a matriculation number or a roll number. No two people will have the same matriculation number, or no two people will have the same roll number. So in cases like that, that is a primary key. That is, it is unique. It is not allowed to be duplicate. It is always assigned to one particular record at a time. So anytime I say set the column, um maybe set the matric number column as the primary key, what I mean is that that primary key cannot have duplicates. It must be unique, and then it can be used to easily locate the record. Number two, there I said a table can have only one primary key. Take note of this. And then it says which should be unique and not null. I will explain that. When I mean unique, it means it can't have duplicates. When I mean not null, it means it cannot be empty. So those are two things that a primary key cannot be. It cannot be a primary a column that is a primary key cannot have duplicates, and then it cannot be left empty. So when you have all these as the attributes of a column, then you can use it as the primary key. All right. You can Let me now give you an example. You can use age as the primary key because two people might have the same age, right? So those are called that's a bad example of you setting age as the primary key. You run into problems because two people might have the same age. All right. So now, what is a foreign key? A foreign key is a column used to link two or more tables together. I will explain it like this. If I have a table called customers and I have a table called product, you will understand what I'm saying now very well. When you create your fact and dimension tables in Power BI, in your fact table, you have to reference the primary keys from geography, from product table, from sales table or sales rep table, all those things. Anytime you are referencing it into the fact table, you are simply setting it into the fact table. You are simply setting it. Now, coming to SQ, have hello, shit, network. Let me.
Yeah, it was breaking before, but it's okay now.
Yeah, sorry, I'm coming. My PC is still loading. My mobile is connected, but the PC is disconnecting. I'm coming, please. All right, let me just continue here and try to explain the foreign key while this one is loading. I was trying to say, sorry, can you hear me from this device? Okay. So what I was trying to say was that let's say that you have multiple dimension tables that all have primary keys table in Power BI, fact table. Remember that the fact there, what it means is that all other keys connecting to the
Foreign
fact
key.
table, they are foreign keys.
Okay, let me continue on my device. So now what it means now is that all other keys are that are connecting to it, they are foreign keys. So same thing is applicable when you have multiple tables in your database that have unique primary keys, but you reference them in another table. In the other table you reference them, they are simply called foreign keys. They may be a primary key in their own table, but once they appear in another table, they are called foreign keys. I don't know if that is clear to somebody, please. Questions if you did not get the difference between primary and foreign key. Yes, I don't know if we are. Is everybody good with the explanation of what a foreign key is, what is a primary key is? Okay, understood. All right. So now we have constraints. I think this will, after constraints, we have, okay, this is where the practical section will start. So now constraints, we have constraints. Constraints are used to specify rules for data in the table. All right. Now, this ensures that the data is accurate, reliable within the table. That is, they set rules to which the data must be entered. Now, there are a lot of them. We are going to discuss them one after the other soon. Then we said constraints can be specified when creating the table or after the table has been created, you alter the table and then make add constraints to it. All right. Now, I'll show you. I'll give you a real world example of where they use constraints. I'm sure each and everyone here at a point in time or thereabout, you have tried to either buy something online or you have tried to use a product online or a service online. The service, let me use Jumia as example. If you don't have an account and then you go to Jumia website and then you try to look for a product, let's say you are looking for a smartphone and you check for the phone, all right? Hello?
Yes, please. We are following, sir.
Yeah, so if you check for the smartphone on Jumia, right, you would definitely be able to look at the product, look at the price, look at so many things about it. But once you hit add to cart, it goes to your cart. Now, you now want to purchase that product. What will it ask you to do? It will ask you that you have to have an account. That is, you should open an account before you can check out that product, right? Am I passing the information? Now the constraint there is that someone who is not a user, that is, you don't have a user ID, then you cannot buy a product. Why? Because if you are not a user, they can't attach the product to an entity for you. That means you have to open an account, have your own ID, so that when you try to buy that product, the product ID will be attached to your customer's ID. Then when you place the order invoice will also be attached to your customer's info or your customer's ID. Now, this is a real world constraint. That is why they would never allow you buy a product without signing in. You have to sign in first. Now, you have an ID. You are in their database. So if you make an order, they will quickly get the order ID of the product you want to buy. And then they will also generate an order ID for you based on the product and the order you are trying to place. When this criteria is met, that is when you can make payment for your product. You can see I've explained two case studies here. You need an ID, you need a customer ID, you need a product ID, and you need an order ID. So we can create a table that we set constraints that if the customer ID does not exist, the user is not allowed to buy a product because we will not be able to attach or reference the product, and then we will not also be able to reference the order ID. I don't know if somebody get this explanation. If you get it, now that is why constraint is important in SQL. It helps us to set rules to ensure correct and reliable information or data for the database. All right. So finally, I think I would stop here. This is the last slide I would discuss. We have common only used constraints in SQL. We have the first one, not null. This ensures that a column cannot have a null value. Not null, I've mentioned it before, it means not empty in a nutshell. That means a column that is set as not null, it must have a record. You get my point? So when a column is set as not null, you can't skip, you can't enter a record into that table without putting a record in that column. That is what it means. Unique is the next one. Ensures that all values in the column are different. I told you before, a good example is the matric number I used. That is, two people can never have the same matric number. So in that case, it ensures that that user does not appear twice. It must be once. All right. So that is what we use unique for. Primary key is also a constraint. This is the combination of not null and unique. All right. Then we have foreign key. It prevents actions that could destroy links between tables, and then it is used to link multiple tables together. You know, I told you, example is your fact and dimension table you did in Power BI. You know, without, when you do your data modeling, without referencing all the fact table, sorry, all the dimension table in the fact table, they will not be linked together. Your visuals will be distorted, right? That's what happens. So now, same thing happens in your database. If you don't set the proper foreign key, your data will be distorted. We have check. It ensures that the value in a column is specified to meet a condition. That, let me give you an example. Let's say you are registering for a program, and then they told you that this program, your age must be this amount or higher. I can now use the check constraint to set it that if your age is less than 18, you can't even register. You get my point? I use that to check. Once that condition is not met, the record cannot be stored, so you cannot register. We have default. It sets a default value for a column if no value is supplied. I'll give you an example. Let's say, which one is common like that? Okay, let's say you are trying to fill a form, and then the form has the column for gender, and you did not select gender. They can make it that whenever you did not select the gender, the default gender should be others or something like that. That is, they just use it to set a default or a column when